Hey everyone, I'm going to do this quick presentation to help support the live lesson that hopefully happens on Monday. So I'm just going to get my pens here ready. So I'm using my computer to record instead of my laptop just because I might be able to do this a little bit more easily. But to start with what our lesson is going to be on, a term is a group of numbers and pronumerals connected by multiplication or division. So when I say a group of numbers and pronumerals, you can think of a term as something like this. We could say 3ab, and that would be right there an example of a term. So I'll just take 1 second, and that right there is our term. That is a term right there. When we say it's connected by division or multiplication, think of it this way. That is actually 3 times a times b. In each one of the spots between the numbers, there's a little multiplication sign. So there's multiplication sign here between the 3 and the a, and the multiplication sign here between the a and the b. So there's actually multiplication signs in there. When we say that there's these things called like terms have the exact same pronumerals. So if I were to say 3ab, I could say 4b, and even though we wrote them in different order, they're still like terms, because if you think about it this way, if I said 3 times 2 or 2 times 3, both of those would give you 6. So both of these, the answer would be 6, and the order doesn't change when we have multiplication. So whether it's 3ab or 4ba, and they are both like terms. Another example of a like term would be something like negative 2ab, and that's another example. You always write the coefficient first, which is the number, and you always write the pronumerals second, and those would be like terms. Those are all like terms. An example of something that's not a like term, and these would be not examples of like terms, would be if I gave you 3b or 4a or negative 5bc. These are all unlike terms or not like terms. You can see all of their coefficients are different from each other, b, a, and b, c. And they're also different from our example that I've given you as well. If I asked you a question like this, which of these are like terms, you need to look at the pronumerals. So let's just take a second and look. If I give you AB, are there any other ones that have just an A and the B for their pronumerals? Well, this one does here. They're just in a different order, but they are like terms. Are there any others that have an A and a B for their pronumerals? And right here, there is another example. After that, I'll just grab purple here. 3b, well, it's just a b by itself, so it doesn't have an a in there. And over here, 5a, well, it doesn't have a b in there. And in this example, 5abc, well, it does have an a and it does have a b, but it also has a c in there, so that also makes it not a like term. And this is just 5 by itself with no pronumerals. So the 3 examples that are like terms here are these 3 are all like terms. So if you're asked to identify or see which ones are like terms, these 3 would be your examples of like terms. Even though this is a fraction, it's still like terms. And even if I give you negative 7ab, that negative doesn't change anything about it. It's still a like term. If when you're given examples like this, to simplify, what I always do first is always write my like terms together. So I write my x. Next I look and I see that this is a like term. It's both the number and the sign in front of it with the pronumeral. So I write minus 2x. The next thing I'm going to do is I'm going to write my next term, which is 3y, with the sign in front of it. So plus 3y. And finally, again, with the with the sign that's in front of it, minus 5y. All right, now we can simplify further. My equal sign again. And whenever you have just x by itself, I'll just take 1 second and just say, whenever you have x just by itself like this, it's the same as saying 1x or 1 times x. In algebra, we don't write our 1s. So if you ever see a pronumeral all by itself, it does mean 1x. So in your head, think of it as 1x. And I'll try to see if I can make that a little bit neater. See if my eraser will clean that up just a bit here. That's not bad. So you can think of it as 1x, which is no problem at all to think of it that way. There we go. And so what's 1 minus 2? You have $1 and you spend $2. What do you have left? You have negative 1x. Next, we think about this part next. We think of what's 3 minus 5. 3 minus 5 is negative 2y. Now in algebra, we don't write our 1s. So this would be a correct answer. In best form, it'd be negative x minus 2y would be in best form. And again, we don't write our 1s, so that would be y. In our last example, similar to our previous one, we have 3x plus 6 plus 4x minus 1. So same idea. Let's collect our like terms. So I'll write 3x first. I then look down for a like term, and this is a like term. It's both the number, the pronumeral, and the sign. So plus 4x. Next is the number 6 and the sign in front of it, so plus 6. And finally, minus 1. What's 3 plus 4? 7, and the pronumeral. And what's 6 minus 1? What's positive 6 subtract 1? Positive 6 subtract 1 is positive 5. And 7x plus 5 is that simplified. Hope that all makes sense to you and kind of helps you understand how to collect like terms, which is what we were doing over here. That is collect like terms, and this is identifying like terms. So those are all like terms. And then I hope this helps you collect like terms and then further simplify them as well. Take care.